Welcome to our exploration of one of the most fascinating questions in modern science. How smart is your brain compared to AI? Today, we're diving deep into the race between biological intelligence and artificial intelligence, examining the strengths, limitations, and future potential of both. Our journey begins with a startling comparison. The human brain, a marvel of evolution, contains roughly 86 billion neurons. In contrast, today's most advanced AI models boast trillions of parameters, but what does this mean for intelligence? As Dr. Sarah Chen, a leading neuroscientist at Stanford, explains, the brain's complexity still outstrips even our most advanced networks. It is not just about the numbers, it's about the intricate web of connections and the ability to adapt, but can your thoughts truly match AI when it comes to math, language, creativity, and more? That's what we're here to find out. Intelligence isn't just about crunching numbers. It encompasses reasoning, learning, feeling, and adapting. While AI excels at processing vast amounts of data and identifying patterns at superhuman speeds, the human brain possesses an unparalleled ability to rewire itself, adapting to new skills and environments through neuroplasticity. This begs the question, which matters more, speed or flexibility? As we delve deeper, you might find your opinion shifting. When it comes to raw processing power, the numbers are staggering. A single modern GPU can perform quadrillions of operations per second. Neurons, by comparison, fire at a relatively sluggish hundreds of impulses per second. Dr. Alex Patel, an AI engineer at a leading tech company, puts it bluntly. When it comes to raw arithmetic, AI already outpaces us by orders of magnitude. It's not even close. This computational advantage has led to some impressive victories for AI in narrow tasks. Chess solved, Go crushed, even in fields like cancer detection, AI rivals top radiologists in accuracy. Take DeepMind's AlphaGo victory in 2016, a watershed moment that showed AI could master complex strategic games. More recently, we've seen AI models scoring 9% above the human average in math benchmarks and outperforming humans by about 2% in the superglue language test. But before we crown AI as the undisputed champion of intelligence, let's consider the human advantage, adaptability, and emotion. Dr. Emily Zhao, a cognitive psychologist, emphasizes this point. Machines excel at rules. People excel at nuance. When context shift or empathy matters, the brain shines. AI lacks genuine emotion, real-world understanding, and self-awareness, traits central to human intelligence. To illustrate this, imagine an AI attempting to interpret satire. While it might excel at analyzing text patterns, it often misses the subtle cues that humans instinctively grasp, leading to comical misinterpretations that would have us in stitches. But how do we measure these different forms of intelligence? For humans, we've long relied on IQ tests to gauge reasoning, memory, and problem-solving abilities. For AI, we use benchmarks like MMLU or GPT exams to assess task-specific performance. The AI index scale sets 100% as average human performance. Recent models have surpassed humans in narrow domains, but they still struggle with generalization, applying knowledge across diverse contexts. It's crucial to remember that benchmarks can embed bias. High AI scores don't necessarily translate to real-world wisdom or understanding. As Dr. Zhao cautions, we must be careful not to equate task performance with true intelligence. The ability to pass a test is not the same as genuine comprehension or creativity, so where does this leave us? Is it a competition between brain and silicon, or is there a more promising path forward? The answer, increasingly, lies in collaboration. The sweet spot isn't in pitting human against machine, but in finding ways for AI to augment our strengths while we guide its growth and application. We're already seeing this synergy in action. Software developers use AI-powered tools like IntelliSense to boost productivity, combining human creativity with algorithmic assistance. In chess, Centaur Team's human players partnered with AI often outperform both solo humans and AI opponents. Perhaps most excitingly, research into brain-computer interfaces promises to enable a two-way dialogue between our minds and machines, opening up unprecedented possibilities for enhancing human cognition. As we look to the future of intelligence, it's clear that we must evolve alongside AI. This means prioritizing skills that machines can't easily replicate: emotional intelligence, creativity, ethical reasoning, and the capacity for lifelong learning. Imagine a world where young learners master not just coding, but prompt engineering, the art of effectively communicating with AI systems. Picture global teams leveraging hybrid intelligence to tackle complex crises, combining human insight with AI's analytical prowess. The smartest future isn't one dominated by AI alone. It's a future where AI is guided by the best of humanity: our values, our creativity, our empathy. As we conclude our exploration, remember this: your brain, with its incredible plasticity and emotional depth, remains a marvel that even the most advanced AI can't fully replicate. But by embracing the strengths of both biological and artificial intelligence, we open the door to possibilities beyond our wildest dreams. The race between brain and AI isn't about who wins, it's about how we can all move forward together, pushing the boundaries of what intelligence can achieve. So, the next time you marvel at an AI's capabilities, take a moment to appreciate the extraordinary organ inside your skull. It is not just smart, it's the key to unlocking a future where human and artificial intelligence work in harmony, creating a world limited only by our imagination.